Hi, this is Stephanie Andronicus, and this is collecting like terms. Like terms, they contain exactly the same variable or variables, or none at all. So some examples of that is 2a plus a, 6xy minus 3xy, 2x squared plus 3x squared, ABC plus ABC. So in each example here, you can see that variable are identical to each other in every expression. Yeah. So you can think of these as like families. So that's the A family, the XY family, the X squared family, etc. They've got to be exactly identical. Unlike terms. So these are different variables. And as you can see, you've got A and B, Y and Y squared. Even though there's the indice is the only difference there because they're still Y, they are in fact different. Then you've got AB and AC. They are different combinations. You can't just have one. So therefore, they are unlike terms. You cannot collect those together. So example number one, let's work through some here. So we've got A plus 2A plus 5A. So having a look at these, one strategy that I like is boxing up strategy. So ensuring that you put a box around the like terms. So in this case, you've got an A there, a positive 2A there, and a positive 5A there. And I like to box them up and link them together to show that everything that is part of the A family are boxed up and boxed up in the same colour in the same way. So everything in one of these boxes can be brought together because they are like terms. So my equal sign, I'm lining up on the left every single time, and I know that I've technically got 1A here, I can think of it as. I've got 2 here and 5 here. So 1 plus 2 plus 5, I know I'm going to have 8A altogether. Example number 2. Boxing it up. I'm looking for like terms. So straight away, I'm going to start with the E family. So 5E. I look across. This term does not have an E, so I can't box it up in the same way. But this term does. So it's identical. It's not an E and an X or anything else. It is an E and an E. They are identical, so I can collect those. They are like terms. Having a look here, we've got an 8 and a 5. Both of those do not have any variables, so I actually know that those two are like as well. So I can link those, box them up in a different colour or even with a different sort of shape. So again, equal signs on the left. I'm going to start with the first one. They are linked together, so I'm looking at the 5E subtract 4E. 5E subtract 4E. So that's just going to leave E, just 1 left over. And remember, we don't put the 1 there as a coefficient. It's just E on its own. And we've got 8, positive 8, and a positive 5. So 8 plus 5 is positive 13. Example number 3. Here, looks a little bit more complex, but first we need to start boxing it up. So we've got the A squared, B squared family. That is a whole term, so I cannot go separating that out. Here's the A squared family, and here's the B squared, but this is the A squared, B squared all together. So actually, I can't box any of these up together. So this is the final answer. There is nothing I can do about this one. Example number 4, we've got the J squared K family. I'm looking across Is there any other j squared k family? That's the jk squared. That's a little bit different. Nope, here we go, j squared k, great. So we can box that one up, we can box that one up, and then link them together. So here we go, it's all 1. We know that's 1, but we just don't have it there, so we can write that in for us if we wish. So it's 2 subtract the 1, so that's just going to leave the 1 j squared k left, and of course then we bring the remaining term down. So we bring it down as it is. Okay, the last example I have for today is we've got 5mn to the power of 4 subtract 9m to the power of 4. M plus 7n. Now, it looks on the surface that we don't have any like terms here. So when we look a little closer though, we might notice something. So here we've got an m, we've got an m, we've got an n to the power of 4, n to the power of 4. Even though these variables are in different orders, technically these two terms are alike. So we can box these up, link them together, and begin to calculate. So we've got 5 subtract 9. Straight away we can put down the negative 4. When it comes to variables though, golden rule, we want to try to have them within each term in alphabetical order. So we're going to put mn to the power of 4, and then of course we bring the last term down, so plus 7n would be that answer. Okay, last but not least, a bit of a summary. So to recap, identify like terms by boxing them up. Like terms must have identical variables. As I mentioned, within a term, they may be in a slightly different order, but we want to default to alphabetical order, and they have to have exactly the same identical variables involved. Use your BIDMAS rules. Very important that we still take them into account where we can every single time. And last but not least, simplify as far as possible. Sometimes it means that we will have more than one term left in the answer, and sometimes it will mean that we just have one term left, and that's okay. Thanks, guys.